So today, as we move on, we're going to be looking again at random sampling. More specifically, we're going to be looking at systematic sampling. Systematic sampling, have you seen it before? Where are we most likely to see it? What are its pros and cons? And most importantly, how do we take a systematic sample? Systematic sampling is the favourite of factory production lines. Industry loves to use systematic sampling. What we do is we basically take one item at a regular interval and test it. So maybe we have a time interval and we take one item every hour from the production line. Maybe we take every 100th item that's being produced and we test to see what its quality is like. This is systematic sampling. The way to take a systematic sample is initially we're going to number each of the sampling units. So each of them has been given a unique reference number. Next, we need to actually calculate the interval that we want to use. To do this, we basically take the population size and we divide by the sample size. So I know what regular interval of the population will allow me to have an even spread through the population, picking out sampling units that can be part of my sample. So in this case, the population size is 40 and we're going to take a sample of 10. So 40 divided by 10 lets me know that my interval is to be 4. Now that we know the interval size, we also need to choose a random starting number. Some people in error think that we'd always start with the number 1, but then that takes away the randomness of our sample, because person number 1, item number 1, the first person in the register already knows that they'll be picked almost regardless of the sample size or the interval size. Person 1 would always be picked. So to avoid this and to reintroduce some randomness, we choose that random starting point. So I'm going to use my random number generator. So the limit should be between 1 and the value calculated for k. So set the limits between 1 and 4, choose a random number, and we've got the number 2. So the first sampling unit to join the sample is going to be car number 2. From here, I'm just going to skip forward by the interval. So I'm going to go forward by 4 cars, and car number 6 is also part of the sample. So is car number 10, number 18, and so on and so forth. So 22, 26, 30, 34, and 38. And these are the sample. Now there are some issues here, and if you notice, we haven't even got any red cars in our sample at all. So just by the way that they were arranged, we failed to collect any red cars in our sample, and our sample isn't particularly representative. The other issue comes from whether or not we've randomized the list before we started. Let's say that we had a register, a class register for all the people in the class. Once I choose somebody from the register whose surname begins with A, the next person in the register almost instantly knows they're not going to be selected because I'm going to jump an interval before I pick the next person. The fact that they're not able to be part of the sample means it's no longer random. I should be able to get every single combination of members from that register, every single combination of sampling units to be part of the sample. To ensure that this happens, we should be randomizing the list. We should be randomizing the sampling frame before we begin to choose a systematic sample. That way, even though someone is immediately after someone else in the register, their orders have been randomized, so they do still have a chance of being selected for the sample. So with that, I'll move into the advantages and disadvantages of systematic sampling. So an advantage is that it's simple and quick to use, and you saw how quickly I was able to generate the sample in the example just here. And because of that, it actually makes it very suitable for large populations, for large samples. Not only if I had the sampling frame and I was selecting them from a list in front of me, but also in a factory, if we're on a production line, it is quite simple to just know that every hour, on the hour, you're going to take one of the light bulbs and it's going to be tested. Every hour, on the hour, you're going to take one of the cupcakes and you're going to do a taste test. Or you're going to take one of the mobile phones and you're going to do a stress test. So a systematic sample is quite simple to take, and quick to use. The disadvantages, just like I said, you're going to need a sampling frame. So you do need a list, or you at least need to know an identifying number for every single item, for every single sampling unit. And as mentioned before, if we want to eliminate bias and we want to make sure that this sample is actually random, we need to randomize the sampling frame before we even start. We need to make sure we've mixed up those sampling units and there's no order to them. It's not alphabetical order, it's not chronological order, there's no order to them, but they have been randomized before we gave them their numberings. Okay, and we're just about finished, but before you move on to some practice questions, let's take a quick look at the specification and exactly what it is that students are expected to be able to show, exactly what the examiners are anticipating you will be confident on. While you read through that, I want to quickly remind you that it will be sensible for you to come back and watch this video at a later date, maybe come back in 2 or 3 weeks or before an assessment. And as you watch through the second time round, because you've done your practice, a lot of what you go through here should resonate with you much more. And you have a chance to really embed your understanding of the difficult concepts, the ones that have been flagged up as A-star.